Good evening, everyone. We are doing the practice paper 18 today for 2027 A-level students. In this paper, we are discussing a structured essay question from Unit 1 and Unit 2, the general structured essay question coming for the A-level, the first structured essay, and we will do that part at the end. But before that, we will be discussing some MCQ questions. Okay, some MCQ questions from chemical calculations lesson that we have been doing last month. Especially last week we could cover parameters of composition, then ARR method, limiting reactance. So there are some theories we discussed. So I thought about that. It's good to revise those theories again through questions. Okay. So look at the question. The concentration of Cl minus ions in an equimolar solution containing MgCl2 and CaCl2. So they says there is a solution that contains MgCl2 and CaCl2, and it says equimolar solution of these two components, and it says the Cl minus composition. Okay, Cl minus composition 142 parts per million, ppm. So it's a ppm question. So it's asking, what is the composition of magnesium 2 plus? It's asking magnesium 2 plus composition in ppm. That's what they ask. And the relative atomic masses of magnesium, calcium, and chlorine atoms are given. And there are 5 answers to select. Okay, I hope you understood the question. Now, let's look at this. Look at about this ppm theory. Okay, parts per million. Parts per million. So there is another thing called ppb also, parts per billion, right? So, but both theories share the same basic principle. Okay, so what did I told you in the class? ppm equals to mass fraction of whatever the component we are looking, okay, into 10 to the power 6. Okay, mass fraction into 10 to the power 6. Okay, so if we need the magnesium composition, magnesium 2 plus composition in ppm, we need the magnesium 2 plus mass fraction into 10 to the power 6. Is that clear? Magnesium 2 plus mass fraction into 10 to the power 6. That is how we get the magnesium composition in ppm. I write it here. Mg2 plus composition. We need the magnesium mass fraction of magnesium 2 plus into 10 to the power 6. Okay, so what is this magnesium 2 plus mass fraction? We need the mass of magnesium 2 plus divided by the total mass, okay, and into 10 to the power 6. This is what we need. And we need to write this ppm always because we are multiplying by 10 to the power 6. Okay. So how do we get the mass of magnesium? We can simply multiply moles of magnesium into molar mass of magnesium. And to get the total mass of the solution, what did we do? We could multiply the density of the solution by the volume we consider. Okay, so this is how we get the mass of magnesium 2 plus and total mass of the solution. Okay, then we multiply it by 10 to the power 6. So if you know these values simply, you can substitute and get the answer. Okay, and they gave, so they haven't given us the density or the volume or anything. Instead of that, they gave us another ppm value, which is the Cl minus ppm, right? Okay, now this is the final thing we need to know, but let's start from there. So it's an equimolar solution. What is the meaning of this equimolar? Equal number of moles. It says that MgCl2 and CaCl2 has the same number of moles. Their ratio is 1:1. In other words, let's say if there are x moles of MgCl2, there will be another x moles of CaCl2, equimolar, equal number of moles. If there are 1 mole here, there will be 1 mole of CaCl2. Okay, right. So anyway, this CaCl2, MgCl2, they both ionize or dissociates to give you magnesium 2 plus and 2Cl minus, and this one gives you calcium 2 plus and 2Cl minus. Understand? So if you say there are X moles of this compound, and there will be X moles of other compound also, because it is equimolar, right? And then you will have X moles of magnesium and 2X moles of chloride. And here X moles of calcium and 2X moles of Cl minus. So altogether, how many Cl minus moles will be there? You can say 4X moles are present. Understood? 4X moles are there. Okay, so that 4X moles is represented by 142 parts per million, ppm. Right. Now let's get an expression for the Cl minus composition also. So Cl minus composition, we can say that 142 parts per million is equal to Cl minus mass fraction into 10 to the power 6. Okay, Cl minus mass fraction means Cl minus mass over total mass into 10 to the power 6. Okay, so this will be m total, and Cl minus mass is, you can say, into 10 to the power 6. We can say it is 4x into 35.5. So how did we get this value? Need to explain that. This is the moles of Cl minus now. So then mass of Cl minus is equal to that number of moles multiplied by the molar mass of Cl minus. Okay, so I'll add the units also to make sure that you understand it. So what is the Cl minus molar mass? 35.5 grams per mole. Can you see now? The units are cancelling. Moles to per mole are cancelling to give you a value in grams. Okay, so 4x into 35.5. So that is the ppm value for the Cl minus. Cl minus. Okay, and then if you get the same expression for the magnesium 2 plus composition, we don't know what is the ppm value. Let's say some ppm value, let's say it is y ppm, y parts per million. That is the number, okay, y parts per million. Then that will be equal to how many magnesium moles are there? X. Then magnesium molar mass is 24. X into 24 over m total into 10 to the power 6. So these are the two expressions now. So now you can see, if you simply divide these two expressions, if you simply divide these two expressions, you will get the answer in answer y in ppm. Okay, did you understand that one? So let's say this equation is 1 and this one is 2. If you simplify these two equations, if you divide this equation, this m total x, they will get cancelled because they haven't told us the total mass, no. They haven't told us the density, no. They haven't told us the volume, no. But since we are considering the same solution, their densities will be the same. Their volumes will be the same. Understand? So then there will be no issue with the volume or density. So since it is constant, you can cancel it. That's why I kept this as m total. Okay, so when you divide the two equations, even x also get cancelled, right? I hope you understood the method. So this is how we are going to do. Now let's divide it and see. So I'm going to divide this one by this second one by the first one. So then I can get the y subject here. So 142 is equal to what? 24 over 4 times 35.5. Okay, so if you simplify this, you will get the answer. Right. So y is equal to 24 into 142 into 4, 20, so 35.5. Now 35.5 and 142 is divisible. Why? Because 35.5 into 2 is 71. Okay, 71 times 2 is 142. That means you have 4 times like this. in that 4 and other 4 get cancelled. So you will get the answer in 24. So the answer of the magnesium 2 plus composition is 24 parts per million. Is that clear, Lamai? Is that clear to you? So we simply got two equations and divided. We didn't do such question in our theory class. This is something, a little bit, few steps forward, right? You have to think here. And simply what did we do, since they are not given enough, actually the data is not necessary also, you can see I cancelled them by dividing. So like that, think. Okay, so simply what is the ppm value means? Mass fraction into 10 to the power 6. That's what you need to understand. Okay, so I hope you all understood about that problem. Right, now let's go to the next question. This is from your theory book, you can see. This is a homework actually I gave earlier, page number 13 in calculation tube. It's about a sodium hydroxide solution which is formed by dissolving 4 grams of sodium hydroxide in 100 cubic centimeters of water. So the density is given. It's asking the following mole fraction, molality, and those things. We'll see how to solve that problem too. So first thing, we need the mole fraction. Okay, so mole fraction. So what is mole fraction? Like we did for the ppm, is there any basic expression for the mole fraction? Yes. Okay, you have a basic expression. So if you need the mole fraction of sodium hydroxide, this is the symbol for the mole fraction. What you need to simply do, divide the moles of sodium hydroxide by total number of moles. When you say total number of moles, that means it is the moles of both sodium hydroxide and what is the other component you can find here? Water. So you need the both components number of moles. Okay, so you can easily find the sodium hydroxide moles because you have these grams, 4 grams. But the challenge is finding the water number of moles. So I'm going to show you how to do that one by step. So try to understand. But before doing these sort of questions, think, how do you get the final answer? Always think, then you will realize what to do with the given data. Okay, so since I need the moles of both water and sodium hydroxide, I can, kind of manipulate the data to get the water number of moles. Okay, so you are about to see that one. But anyway, to think what to do, you need to realize what you should do at the end. Okay, I hope you understand. So now let's see how to find the moles of sodium hydroxide and moles of water. Okay, right. That is what important here. So again, in the first question, what was the important thing? Parts per million was mass fraction into 10 to the power 6. That's what you need to get finally as the summary. Okay, now in this question, mole fraction, molarity, three things are asked. So about mole fraction, what you need to know is moles of sodium hydroxide divided by the total mole. So here, what is important? How do we find the moles of water? That is the important part. Okay, now you can see. Okay, first of all, we will find the number of moles of the compound that is already we have. Okay, so to do that, we need molar mass of sodium hydroxide. So atomic masses are given, relative atomic masses are given. Sodium 23, oxygen 16, and hydrogen 1. You will get 40 grams per mole. Okay, and then you can get the moles of sodium hydroxide by simply dividing 4 grams from 40 grams per mole. So we will get 0.1 moles. This is the number of moles of sodium hydroxide. Okay, and then how do we get the moles of water? Now this is the thing. First of all, we need to find the mass of water. Okay, we will find the total mass first. Total mass of 100 cubic centimeters of solution. So please write small statements to make your simplification clear. Okay, so someone looking at your answer should be able to understand. So you are understanding what I'm teaching here because you can read this question treat this as statement given. Understand? Otherwise, it is just some bunch of numbers. Okay. So how do we get the total mass? You multiply the density by the total volume. See, 1.038 grams per cubic centimeter multiplied by the 100 centimeter cube. So you will see 103.8 grams are there. So from this 103.8 grams, okay, sodium hydroxide is there 4 grams. So now you can find mass of H2O by doing what? By subtracting 4 grams from 103.8. Okay, so you will get 99.8 grams. So now this is the mass of water. Okay, so now you can find the moles of water, because you know the molar mass of water is 18. So simply this 99.8 you have to divide by 18 grams per mole. 18 grams per mole. Okay, so it's looks like not divisible. So I'm gonna get a little help from the calculator to do that. But if it is happen to you in the exam, what you should do, you have to get a logbook and do the simplification. 5.54 moles. Okay, now we know the number of moles of water, number of moles of sodium hydroxide. We can now find the mole fraction. Okay, so moles of sodium hydroxide is 0.1. And the total moles will be 0.1 plus 5.54. You can see water moles is considerably higher, no? Isn't it? So 0.1 over 5.64. This is the mole fraction. You can further simplify this one if you want. 0.0177 is the mole fraction. This is how you find the mole fraction. So use the given data. There are no fixed methods for this one. Just understand the given data and do what is necessary. Okay, I hope it is clear. This is the first part, finding the mole fraction. Any questions on this? So remember, ppm was the first question. Second question is mole fraction. So molarity and molality. Okay, so one of this is equal to, one of this is give the same meaning as concentration. So what that parameter? Is it molality or molarity? Huh? So what I told you in the class is concentration has this letter R. So one of these two words, molality and molarity, has a R. Okay, so the one with the R is equal to concentration. Concentration. So how did you got the concentration earlier? Concentration is simply what? Moles of the compound we are looking for. This sodium hydroxide here. We need to divide by the volume of the solution. Okay, volume of the solution. This is how you find the molarity. So what is this molality then? Molality still you have the moles of the compound sodium hydroxide, but you are dividing this one here by the mass of solvent. What is solvent here? Water. So you need to divide this one by the mass of water. This is the difference. Okay. So we have 0.1 moles of sodium hydroxide in 100 cubic centimeters. So 100 cubic centimeters is 0.1 decimeter cube. So the concentration is 1 mole per decimeter cube. Okay, I hope you all got that value. And then let's see to find molality. 0.1 moles divided by the mass of water. Here's the mass of water, but we need it in kilograms. So 0. Divided by 1000 or 0.0998 kilograms. So divide by that. Then you will get the answer in moles per kilogram. So this is also not divisible. So that's why they are not usually asking molality. Okay, because the simplification is difficult. So answer is 1.002 mole per kilogram. But this answer is exactly 1.000. But this is 1.002. Now you can see there is a small difference. But now we'll see how to figure out the question. First of all, I'll put the data in the board. So you have an ammonia solution. Ammonia solution. In that solution, it says you have 30% by mass ammonia. That means if you get 100 grams of the solution, you have 30 grams from ammonia. And then it says the density 0.850 grams per centimeter cube. Okay, so that means if you get 1 centimeter cube, its total weight will be 0.85. Right, and from this ammonia solution, you get 40 cubic centimeters. You get 40 cubic centimeters of ammonia, and then you titrate that one with, and then you react that one completely with sulfuric. The titrate word is not there, but anyway, this is what we are doing. So then as a product, you will get ammonium sulfate. They have given it in words, ammonium sulfate. So it's asking, what is the mass of ammonium sulfate? Or the amount means they are given it in grams. What is the mass of ammonium sulfate you are getting? That's what they ask. Okay, students, I hope you understood the question. They have given the relative atomic masses also. Right. This is 2024 A-level MCQ. Right, now this is the thing. First of all, we'll figure out this compound formula. This might bother you, no? So ammonium is NH4 plus. This is the ammonium ion. It's a cation. And sulfate, you know, it is SO4 2 minus. So the formula of this compound is going to be NH4 twice SO4. This is ammonium sulfate. Okay. And then there is a reaction happening. So 2 ammonia reacts with sulfuric acid to form ammonium sulfate. So that means this is a balance equation. The ratio is 2:1:1. That means now, if you have, let's say, X moles of this compound, you will have half of that moles from ammonium sulfate. So how do we get the mass of ammonium sulfate? Okay, by simply multiplying this number of moles by the molar mass of ammonium sulfate. This is what you are going to do at the end. But in order to do that, we need to find how many moles of ammonia was there in this 40 cubic centimeters. If you can find it, then you can think about getting the answer. So that's what I was telling you earlier. So this question, some students might say it is difficult. Why? Because you can see there are two theories. You have a reaction and the stoichiometry bridge concept. So 2 is reacting to form 1 of the product. So you need to consider this ratio and find the new compounds, moles, and then go to the mass. So this is stoichiometry bridge, remember. And then on the top of that, the question is made difficult by adding these parameters of composition theory. Instead of directly telling the concentration of ammonium sulfate, they have told you some data like this. So you don't know the concentration. You need to find the concentration. Then it is a general question you tried earlier. So that's how they make the question difficult. I hope you understand now. They can make the question bigger by adding these parameters of composition theory data parts. Okay. Right. So now let's see. Now you know about the last part, now how to solve. So let's start the question by finding the concentration of this ammonia solution. Okay, concentration of ammonia solution. So to find it, NH3 concentration. In the theory class, I gave you 3 simple steps. 3 simple steps. What is the first step? You are going to consider 1 dm cube. Okay, and then you find total mass of 1 decimeter cube. Total mass. So for that, you multiply this density 0.85 gram per centimeter cube by the volume of 1 decimeter cube, 1000 centimeter cube. So you will get 850 grams. That is the total mass. Then you find mass of ammonia. What is the mass of ammonia? It has told you only 30% of the total mass. You have ammonia, 30%. Then how do you get the moles of ammonia? The final step is finding the moles of ammonia in 1 decimeter cube. So simply what you have to do, where is this part limit? About this formula thing, I hope you understood it well. How to get the moles of ammonia? So 850 into 30 over 100, and you divide that one by the molar mass of ammonia. Nitrogen 14, 3 into 1, 14 plus 3, 17. 17 is the molar mass. So divide by 17. 17 grams per mole. This is the number of moles of ammonia. Now you can simplify it. You can easily cut these things. And you can see 8.5 times 2 is 70. Okay. So for 85, you will have 170, 85, 5 moles. No? So 5 into 3. 5 into 3, 15. You will find 15 moles are there. So what is the concentration then? 15 moles per decimeter cube. 15 moles per decimeter cube. Okay, so 85 is divided by 17, which is giving you 5, and then multiply by 3, 15. So now, how many moles of ammonia is there? So N equals CV, no? Concentration 15 moles per decimeter cube. Volume is 40 into 10 to the power minus 3 decimeter. So you will see number of moles are 600. So 0.6 moles are there. Okay, 0.6. Now if you have 0.6 here, how many moles you will have from ammonium sulfate? 0.3. Because you need to divide this one by 2. That's how we deal with the rate ratio. And then find the molar mass of this compound. Molar mass. So how do we do it? There are 2 nitrogen, so 14 into 2, 28. And there are 6 oxygen, 6 hydrogen, sorry. And then 1 sulfur and 4 oxygen. 4 oxygen means 64. And get the sum, you will see 20, 130. 130. Okay, so multiply this one by, okay, so multiply this one by 0.3 by 130. So 39 grams. This is the total mass you can separate. Is that clear, Lamai, the method we did the question? Any doubts on this one? Let's see whether that answer is there. No, that is not there. So that means we missed something. So let's go and figure out that quickly. It is 400 centimeter cube, no? Yeah, I got it as 40. So let's simplify that, let's make that correct. It is 400 centimeter cube. So where did I miss then? 15 I got, then I need to multiply here by 400, no? So then it will be 6 moles. 6 moles. So then there are 6 moles, you will have 3 moles of this one. So it should be 390. Is there that answer? Maybe I missed something with the molar mass. Ammonium sulfate. Yeah. It is NH4 twice. Yeah, so then it is going to be 8. So 132. Yes. So into 2. So 396. Okay, some small errors are there. I hope you can understand that. Anyway, be careful with the simplifications. Okay, it's good that they ask these for the MCQs, right? Then we will realize that we made some mistakes. No? Answer is answer. Okay, so now focus on the question number 5. I'll put a diagram in the board. So it says wood ash sample X contain calcium carbonate, potassium carbonate, and inert material. So there is a sample which contain calcium carbonate, potassium carbonate, and inert material. And in the X, molar ratio of calcium carbonate to potassium carbonate is 2:1. So here the molar ratio is 2:1. 2:1 ratio is there. That means if there are 2x moles, you will have x moles of this compound. That is what it tells. Directly change the value into some moles, okay, putting x. And then in 1 gram of sample, so you are considering 1 gram of this whole sample. 1 gram. Reacted with excess HCl, the concentration of and the volume of the HCl used. So now this is reacting with HCl, no? So we have HCl solution. HCl concentration 0.3 and volume is 25 centimeter cube. And after the reaction was completed, remaining HCl was quantitatively collected and titrated with. Okay, so can you understand where this is going? So when you react this one, some HCl will remain. So we had a specific name for this kind of a titration. What is that? So we find we had excess HCl, excess known amount of is added first. And then to find the remaining amount, we titrate the remaining amount with another base, sodium hydroxide. Sodium hydroxide from 0.1 m solution, 15 cubic centimeters are used. So what is the name? Anyone remember? What is the name we use for these sort of titrations? It's a good question, see? Anyone? Reverse titrations. Okay, very good. Reverse titrations. Okay, good. Because here's the story. We add an HCl excess, no? Okay, so to find how much HCl remain, we titrate that one with sodium hydroxide. So it's a reverse titration. Okay, reverse titration, right? So moles of sodium hydroxide. Moles of sodium hydroxide, you have 0.1 mole per decimeter cube, 15 cubic centimeters. So that means 1.5 into 10 to the power minus 3 moles. So now this sodium hydroxide and HCl, they react in 1:1 ratio to form sodium chloride and water. This is the reaction. So if it is essay question, you need to give this reaction also. Then you will be having some marks for that. So we can see now moles of HCl remaining. Moles of HCl remaining, the same value, no? Since it is 1:1, 1.5 into 10 to the power minus 3 moles. Now we can find how many HCl moles we added. Moles of HCl added. So added moles of HCl, you can simplify by multiplying the number of moles, 0.3 mole per decimeter cube, by the total volume, 25 centimeter cube. Okay, so you will see 7.5 into 10 to the power minus 3 moles. So now you add 7.5, you can see 1.5 is remaining. So how many moles are reacted actually with this sample? The difference. No? So then you can write that one. So moles of HCl reacted with sample. This is reverse titration now. It is equal to 7.5 minus 1.5 into 10 to the power minus. I got the minus 3 as a common factor because space is not enough. So it is 6.0 into 10 to the power minus 3 moles. This is the number of moles of total HCl reacted. Okay. Is that clear? That reverse titration thing up to there? Any problem, any doubt on that, and go through that part again, Puti? Now, when we are coming to the best part of the question, we are using this to number of moles. So I earlier told you them as x and 2x. Right. So after the reaction, so what is this reaction happening with HCl? It is not given here. Anyway, carbonates are reacting with HCl to form carbon dioxide and water. Okay, so you need 2 HCl. This one is also need, 1 HCl. No, it is still carbonate, no, so 2 HCl. 2 KCl and carbon dioxide water. Okay. So if you have 2x moles of calcium carbonate, you will be needing 4x moles of HCl with that one. And if you have x moles of potassium carbonate, you will need 2x moles of that one. So all together, if you put this one, it is 6x moles. No? Understand? 6x moles. So that 6x moles is equal to 6 into 10 to the power minus 3, which is coming from here. Okay, because this is the reacted moles, no? Actual moles. No? So you can find then x is equal to 1 into 10 to the power minus 3 moles. See, 1 into 10 to the power minus 3 moles. So now we cracked the question. So what's the last part they're asking? Percentage of calcium carbonate. So we know the calcium carbonate number of moles, 2x. Okay, so how many calcium carbonate, what is the calcium carbonate percentage? So you need the moles of calcium carbonate multiplied by the molar mass divided by the total mass into 100%. So number of moles, 2 into 10 to the power minus 3. Why did I got 2? Because calcium carbonate is 2x, no? Okay, into molar mass is calcium carbonate. If you add calcium 40, carbon 12, oxygen 48, you will get 100. So multiply by 100 grams per mole and divide by the total mass 1 gram. And then multiply into 100%. So what's the answer you are going to get? 20%. Okay, now let's go to the question number 6. I'll put the question theory data in the board. So it says FeCl3 reacts with NH3 and water. NH3 and water to form FeOH thrice and ammonium chloride. So they have given us all the reactants and all the products. So when you balance these kind of equations, you are using inspection method. Inspection method. So you check the two sides and put numbers. Okay, and it says this amount of grams from each reactant is used. So from FeCl3, 97.5 grams. From ammonia, 34 grams. And from water, 27 grams. So we can convert these gram values into number of moles because we know the relative atomic masses. See, 56 is for N, it is given. So what the question is asking, what is the maximum quantity? Maximum quantity you will be getting from this iron hydroxide, FeOH thrice. Okay, so we are applying here added reacted remaining ARR method. ARR method. So we did plenty of questions earlier. You can go through that. The recordings are there. Yeah, I gave some advices also in the class. So how to, kind of recover from the previous problems you are having. So the best option is going through the papers that we did earlier. Going through the recordings is the second option. I mean the theory recordings. First go through the paper class recordings. You will realize so many things and it will get better. Okay. Right. So these questions were there, very common, and we did discuss this recently too. Okay. So anyway, how do we start the question? By finding the number of moles. So moles of FeCl3, first of all, we need the molar mass. So 56, 3 chlorine means 35.5 into 3. 5, 1, 15, 16, 1, 3, 106.5. So 106.5 plus 56, 106.5 plus 56, you will get 162.5. So let's divide this one by moles of FeCl3. 97.5 divided by 162.5. 162.5. Okay, so just imagine it is 975. And imagine this is as 160. So if it is 160, 5 times 160 will be 800. So if you put another 160, it will be 960. So but our 175 is a little bit more than that. No? That means now you have 2.5 also. So you can guess and think. You can feel the value. It is going to be 6 times. No? Now we will multiply this one and make it sure. You multiply by 6. No? Let's see what is going to be the answer. 12 plus 3, 15, 36, 37, 975. Yeah, it is divisible. So it's going to be 0.6. So that is the number of moles you added. You don't need a calculator for that one. Huh? Okay. So these are MCQs now. Just guess the number. I hope you understood the method. And then the next thing, we need to find the moles of NH3. Molar mass of NH3 is 17 grams mole, 14 for nitrogen and 3 for each hydrogen. So 34 grams divided by 17 grams per mole. It's very easy, you will get 2 moles. And moles of water, you need to divide this 27 grams by 18 grams per mole. You can see it is divisible by 9. So 3 over 2, 1.5. So here's the number of moles, 1.5. But we forgot to do one important thing. What is that? Balance in the equation using inspection method. We'll do that. And then we can go to the reacted remaining those rows. Okay. Right, so we use the trial and error method. We put some number. If it is not suitable, you're going to change the number and apply another number. Right. So, but if you think carefully, you can see there are 3 oxygen atoms here. So there's only one place that contain oxygen in the other side. It is water. So we can think about 3 water. 3 water. Okay. And there you have 3 chloride ions also. Then it should give you 3 ammonium chloride in this side. So then we can put 3 in front of this ammonia too. So if these numbers are not suitable, I'm going to erase them and do it again. But before that, I'm going to check about the hydrogen atoms because that's what I didn't touch now. 3 into 3, 9, 9 plus 6, 15. 3 into 4, 14. That's 12. 12 plus 3, 15. Yeah, it is balanced. So the ratios are 1 is to 3 is to 3 is to 1. 1 mole of this one is reacting with 3 moles of ammonia and 3 moles of water. So then, to react with 0.6, how many moles you should have? 3 times like that, 1.8. And 3 times like that, 1.8. So, but you don't have 1.8 no? So, not enough. You don't have 1.8, see? You only have 1.5. Therefore, that 1.5 will react. Okay, and accordingly, if this 1.5 reacted, this side 1.5 will react. And this side 0.5 will react. 1/3 of that one. So 0.1 is remaining, 0.5 is remaining. Here nothing remaining. So we call this reactant as what? Remember? Limiting reactant. This is the reactant that limited the reaction. If you have more water, then this will be continued more forward. And in this side, 0.5 moles will be given. 1.5 moles will be given. Okay, so 0.5 moles are formed by this reaction. So this is the data we need, 0.5. So now let's find the molar mass of iron oxide. So iron 56. 3 oxygen means 48. 3 hydrogen means 3. 14, 17, 1, 107. So you need to multiply this one by 107 grams per mole. So it's multiplying by 0.5 means dividing by 2. 53.5 grams. The answer is there. Answer is answer 3. So these are the MCQ answers from chemical calculations. Most of them are homework questions I gave in earlier classes. Okay, and since they are homeworks, please add these reviews to your theory book also. You can attach a small paper and make it a nice note. Right, now I'm going to show you the marking scheme of the structured assay question. First one, ionic radius of isoelectric monoatomic ions. Isoelectric monoatomic ions means the ions with same number of electrons. Sodium plus, magnesium 2 plus, aluminium 3 plus, like that. So it says that their size decreases. Okay, radius decreases when the nuclear charge increases. It's true. So you know magnesium is having more nuclear charge than sodium. Okay, and magnesium, therefore magnesium 2 plus ion is smaller than sodium plus. So that statement is true. You can write there. That example, sodium plus is larger than magnesium 2 plus. That is the example. And then the next one, an acceptable Lewis structure can be drawn for OF4. So you can't draw an acceptable Lewis structure for OF4. Why? Because if you try to draw that one, you will see there will be more electron pairs around oxygen, but you can't violate the octet rule for oxygen. This is the structure you will have for OF4. There will be lone pairs on fluorine, but the point is, look at oxygen. It is having 5 repulsion units. So cannot violate octet rule. So in the second energy level, you can keep maximum of 8 electrons. So you can't draw OF4. So second statement is false. False. For first statement, you can write this example if you want to do a more extensive explanation. This is better. Isoelectric series, remember? And in this direction, their radius decreases because their charge, or because their nuclear charge, the number of protons increases. And the next one, third one, 3 resonance structures with equal stability can be drawn for nitric. That is wrong. You can't draw equally stable structures because there will be a double bond. There will be a double bond resonance structure, and this will be the other one. And both these structures are equally stable. But the structure you are drawing like this, there you have a positive charge on oxygen. These structures are not complete, but however, you can see this resonance structure is unstable because you can see a positive charge on oxygen. So telling that equally stable resonance structures there for the nitric is again false. And then look at the fourth one. Pauli's exclusion principle exclude the possibility of the presence of third electron. Yes. It says the maximum electrons that can be there in an orbital is 2. You can fill only 2 electrons in opposite spins. Okay, so you can't put a third electron there. Okay, remember, just go through the Pauli's principle. You'll understand it more. And then the fourth one, standard lattice dissociation enthalpy of CaCl2 is less than. That point is not there for you yet, Lamai. So just you can leave it blank. Okay, you can leave it blank. That you will learn that one in energetics lesson, the unit 5. So in this month, in the last week, we are starting the unit 4 gases. Okay, a little bit of introduction. So after finishing the unit 4, you will start unit 5, which is from energetics. We will discuss about this enthalpy thing there. Okay, sorry I put it there. Anyway, look at the 6th one. Greatest difference in ionic radius is there between magnesium 2 plus and calcium 2 plus. Now these cations are sodium, magnesium, potassium, and calcium. You know, there's this mirrored effect for these cations that are there in the same adjacent 4 boxes, and for the elements, and their cations also following the same pattern. So the largest difference will be there between magnesium 2 plus and potassium plus. Okay, the largest and the smallest. So what they have given here is another combination. Sodium, magnesium, and calcium, that is wrong. So can you understand that one now about that small 5 statements? And this is the Lewis structure you can draw. Remember, it says 2 negative, minus 2. Don't forget that one. Most students are getting the wrong answer because they miss to see this minus 2. It's something you need to practice more. And then it's asking the oxidation numbers, shapes. Okay, we will be discussing oxidation number in this week. I hope you understood that one. And these are the resonance structures you can draw for this structure. Since you have 3 pi bonds, you can change the location of these 3 pi bonds, and you can get total of, including the given one, you can draw 5 resonance structures for this whole molecule. Right, so this table is also, I think, it's very easy, fine. And what is important here is this sulfur. This sulfur, can you see, it is sp2 hybridized, but still the sp2 hybridized means it has only one p orbital remaining. Only one p orbital remaining. Okay. So with that p orbital, it can only make one 5 bond. But you can see here, sulfur has made 2 5 bonds. That means, okay, so there is another orbital, unpaired orbital in sulfur, which comes to make 5 bonds. What is that orbital? It is not p. It is a d orbital. Okay, sulfur has a d orbital for the 5 bonds. I explained this theory in earlier paper classes. Paper 15, 16, 17, you can check. This theory is there. I just added the question because of that point. Just to remind you, you can see when they're asking the orbitals that participated for the 5 bonding, you can see S2, one 5 bond is made with 2p, sorry 3p, other 5 bond is made with 3d orbitals. And then ask the electronegativity, bond angle, those things are easy. Okay. So oxygen electronegativity is always higher than other elements. Then carbon is having a lower electronegativity, sulfur is having a high electronegativity. And then nitrogen, when you consider nitrogen N1 is sp hybridized. Therefore, it is having more electronegativity. Like that you can see. So S2, this variation is not for you. I told you about this one. This is the correct order. Okay. But according to polling scale, since the electronegativities are same, no? So then students can write in this way also. But anyway, don't write multiple answers. Always stick to the sulfur is more electronegative point. Okay. Yeah, in the bond angle, I added plus or minus because yeah, one of you asking that one. That is how the marking scheme gives. Okay, it is giving you a range. So, but when you are writing, this is a marking scheme. I forgot to tell. Right? It's a marking scheme. And when you are writing answers in the A-level exam, don't write plus or minus and add these values only. You have to say a number, as I told you. Okay, if it is 117.5, you just write that number. The plus or minus indicates some students might write 118. Okay, so then they also get the marks. That's why. Okay. Right, and look at this part C. It's about secondary interactions. So HCHO. HCHO is forming dipole-dipole interactions and London forces only. Because it is a polar molecule. Most of your students are getting wrong here. Because HCHO don't form any hydrogen bonds. If you draw the structure, you will realize that this is the structure of HCHO. So there are no hydrogen connected to oxygen. So it can't make hydrogen bonds. Okay, so but it is a polar molecule. So it will make dipole-dipole interactions. And like any other molecule, polar molecules are also forming London forces. So that's why the two answers, dp and London is there. And then carbon dioxide is an unpolar molecule, so it will have only London forces, right? And water sample containing dissolved I2. So within water, you have hydrogen bonds. And between water molecules and I2, you will have iron dipole. Sorry, dipole. Yeah, sorry, I2, no, I2. You have dipole-induced dipole interactions. I2 is an unpolar molecule. Okay, so this hydrogen bond is there between water and water, okay? It's a good question. And then the boiling point thing. So 2-methyl propane and N-butane. So you might not know these structures yet. So anyway, 2-methyl propane means you have a branch. This is the 2-methyl propane. And N-butane means you don't have any branch. So you can see it's having more surface area, no? More London forces. But here, a fewer number of London forces. Understood? So that is explained using these 4 statements. You can see how they are allocating marks also. Study the marking scheme. Right. See, 2-methylpropane and N-butane both are nonpolar and they have London forces only. But 2-methylpropane is a branch molecule. So if it is branch, then low surface area. And N-butane is not branch, so it will have more surface area and more London forces. But 2-methylpropane or the branch one will have lesser number of London forces. That is what you need to write. And that statement they have given is false. And the last part is here about arranging them in ascending order. So covalent nature increases in this way because you can see the two cations, three cations actually, barium, calcium and magnesium. Those are group 2 cations, they all have the same charge. Okay, and then their polarizing power increases when the size is low. So magnesium 2 plus is the smallest one. So then it will have the highest polarizing power and most covalent character. Okay, and then when you get the chlorine, bromine or fluorine, you can see their sizes increases, fluorine, chlorine, bromine, and bromine will have more covalent character. The polarizability is high. It's you can easily understand that one using polarization power and ability. Compare the cations separately and compare the anions separately. Okay, then you can understand that. And the final one is about carbon monoxide, bond length. You can see the structures I gave you here in the green color. Carbon monoxide is having a triple bond. And H2CO, this is the structure, it is having a double bond. But look at the other two structures, HCO2 minus and CO3 minus. Those are having carbon oxygen double bond and carbon oxygen single bonds also. Right, and for the HCO2 minus, the second molecule, you will have one resonance structure. So actual structure is a hybrid of the other these two resonance, and you can find the bond length will be in between single and double bond length. Bond order is 1.5. But for carbonate, remind your theories we learned, and carbonate bond order is 1.33. Okay, so it is more having single bond character. That's why it is having the largest bond length. Okay, so like that you can understand it. I didn't went into much long explanation. I just briefly told you the answers because this is not the area we have our main focus. We did similar questions to this one earlier. So my advice is, if you are having more doubts here, go through our previous SCQ1 discussions. Okay, and there may be we did the all past papers also, right? Then you may have more than 5 or 6 questions to study, so you can get a nice idea from those discussions. Okay, don't miss them. If you feel that you need more revision from that, I recommend you to go through those recordings. Okay, but for the calculation parameters of composition revision, today is the best recording you have. Okay, right. So I hope you understood today's discussion. Like I said, from next week we'll be doing our evaluation test paper discussion.